In this example, I want to talk about retention indexes. Retention indexes provide a way to verify a correct answer given its retention time. In this particular method, at 0 minutes and 0 seconds, we can start with retention indexes of about 350, and at the end of the method, at 10 minutes, we're going to end at about 1350. But first, we need to know how to look up retention indexes. Let's start by opening up our NIST program in the top-hand toolbar. In this program, we're going to go to the Names tab at the bottom, and now we can search any of our chemical identifications in the upper left-hand corner. So let's start with our first chemical identification. I find that to be benzene, and so I'll simply just type benzene up in this top-hand toolbar. If I scroll down, I can find a column or a label called retention indexes, and benzene has about a 650 retention index. That makes sense, given 350 being our lowest possible one, and this retention index, this chemical, being fairly early in the run. If I select a second chemical, we can go over here. I have O-xylene. You would expect, since this is later in the run, that would increase from 650 to some higher number, and in this case, we're at close to 900. And going to the end of the run, I could confirm this peak, which is 112344 hexachloro-1,3-butadiene. There's a problem here. That name is far too long to type up here in our search bar. So another way to search a chemical is to simply highlight its CAS number, copy it, and now we can go to search by CAS, and it can pull up that chemical. This chemical has close to a 1200 retention index, which also makes sense given our 1350 cap of retention indexes at the very end of the run. A second way to use retention indexes can be to verify or spot false positives. In this example we talked about in our AMDIS, we had carbon tetrachloride, but we also had an identification for trichloronitromethane, and we needed to find out which one was the correct answer. One way to do that is to compare it to a known. Here we had benzene, which we knew our retention index was about 650. Let's pull that back up. So if two chemicals are co-eluting, in this example, benzene is co-eluting with another chemical with a 117 fragment, either carbon tet or trichloronitromethane. So whichever one of these two chemicals has a closer retention index to the peak it shares, benzene, is going to be our correct answer. Let's start by looking up carbon tetrachloride. Carbon tetrachloride, compared to the 650 of benzene, is slightly higher at 658, but almost exactly the same. Comparing that to our trichloronitromethane, we'll notice that trichloronitromethane is close to 100 retention indexes later, which would mean that it would share a separate peak, or it would have a completely separate peak. It would not co-elute. So in this case, I can rule out trichloronitromethane as a possible identification for the right-hand side of this peak, and I can confirm carbon tetrachloride as the correct answer. Thank you.